This week we will be focusing on our Unit 2 exam. I have a review folder available for you, and that's what we're going to do in this video is cover the Unit 2 lab exam review. If you go to Blackboard, under the Assignments button, you should find this Unit 2 review folder at the bottom for Week 10. And in this folder you will find the Unit 2 objective review. This document is just a list of all of the terms and functions that you'll need to know how to use and know how they work, not only for the lab exam but primarily for the multiple choice true-false exam. So these are just a listing, a library of definitions, a list of definitions that you'll need to know. So that's for your own benefit. Definitely read through this and familiarize yourself with that before you go into the exam. So what we're going to focus our time on is this Unit 2 lab exam review. Some of you may have just finished the Unit 1 exam. You had a full month time window to work on that. This Unit 2 exam you will not have to show up at any of our testing centers for. You can just complete this exam on your own at home. And here is the Unit 2 exam button link. I've already made it available. But before you take that exam, I would go through this review, and you will also receive points for this lab exam review, so you do need to complete it. Okay, so if you click on this Unit 2 lab exam review instructions button, or the attached file, I should say, this gives you a list of instructions for this Unit 2 review, and this is going to mimic pretty much what you're going to need to do for the test, for the Unit 2 exam. The instructions read like this: write a C++ program that stores physics formulas. The program should have a header file that contains two functions, one that gets formulas and one that puts formulas in a file. Function that receives the formula should create a vector and return that vector. Function that places formulas in the file should receive a vector and have a void return type. Okay, we already have a header file that does that. We are just going to attach our database or data accessor.h file and use that, implement that in this solution. Then I want you to have a main function with a menu that has options to save formulas or view formulas. And then here I said, for simplicity's sake, you can hard code the name of the file into the program. What I'll have you do here, if you want to, you can just use what we've already got in the file's input-output expansion pack, where the user types the file name in, and then you would allow the user, they can just type whatever file name in they want. Since we already have that structure, you can do that. If you want to, I suppose you could comment that portion out and then put a single file name in. That'll save maybe a little bit of time when you're debugging, so that's really up to you. I'm going to allow the user to go ahead and type the file name in. Instruction 3 says save formulas option should create a vector, receive user formulas, then pass the vector, the function in the header file. I should say pass the vector to the function. Then the retrieve formulas option should call the function that gets formulas from the file and place the return vector into a local vector. It should then read through the vector and display the formulas. Okay. So to get started, I am going to create a brand new dev project. And I'm going to call this last name first initial Unit 2 review console application. And I will create a folder for it. Okay. Okay, the first thing that we need to be aware of, the dev compiler doesn't quite behave the way you would expect it to, especially those of you who have used Visual Studio in the past. Over here on the left, you can add files or so if I right click on the project level, Monroe J Unit 2 Review, and then do add to project, you can pick existing files and add them to the project, but what it does not do is it does not make a copy of that file and put it locally where it can be used. So the quick easy solution, without having to dig into this compiler anymore to figure out how to get that to link properly, what I suggest you do is go to your folder location, and for me, let's see, C++ projects, whoops, wrong documents. Okay, so C++ projects. I'm going into my files input-output expansion pack, and actually I think I left it in the files IO. Okay, here it is. Here's my data accessor. I'm going to copy that, and then I'm going to place a copy into this Unit 2 review folder. Okay, so I've made a copy of that file. We might want to make some edits to this header file, and so that gives us a local copy just for this project. And then the next step here would be to add that file. I'm going to do add to project, and then there I can see it sitting right there, data accessor. Okay, so I'm definitely going to include that file. And remember, when we include our user created header files, you use quotes. And I'll put some information here, name, date, description. This program will save formulas into text files and allow the user to open and view them. Okay, so making it simple here. Okay, copy and paste is your best friend as a programmer. If you have other projects that have the code that you need, copy and paste it. So I am going to open in my files input-output expansion pack. I'm going to open up the C++ file. Actually, yeah, once again, I didn't create a new project, it doesn't look like. Okay, so this CPP file has a lot of what I need already. I am going to, you might be tempted to just copy and paste the whole thing. The only reason I would caution you against that, the more you copy and paste, the more there is that you'll probably need to change, and you might get distracted and forget to change it. That's happened to me a lot in industry, where I'll have the something just slightly wrong or slightly off because I copied and pasted and didn't make the adjustments for my new project from what it was in the old. So I would just recommend copying just a little bit at a time. So the first thing I'm going to do is I'm going to copy this bit right here, and let's see. I'm going to copy pretty much all of the main function. We'll start with that. Okay, so in my main, I'll go ahead and paste that in here. And I'm going to make a slight adjustment here. Instead of using an integer for the user's choice, I'm going to use a string. And I am going to initialize it to the empty string. And that way I don't have to use this cin and this get character. And I'll also so I'm going to have a get line function that reads the user input and then stores it into string choice. That way I can deal with strings. And then up here, that while string choice is not equal to 4, that's the integer 4. I'm going to have it be the string 4. If you'd like to, you can change these to A, B, C, and D if you'd prefer that. And I'm going to keep with the numbers and just use the strings 1, 2, 3, and 4. So while the string choice is not equal to 4, I want this loop to continue. And these switch cases receive integers or characters, I believe. We're reading in a string. I'm just going to switch. I'm going to change this entire structure here and make it just an if, else, if, else. So if string choice is equal to 1, the string 1, then I'm going to call this function add names, and I'll change the name of that here as well, but let me just change the structure first. Else if, and copy this string choice, if it's equal to 2, and call a different function. Else if, and this time I'm typing it, if it's equal to 3. And here in our project, we only have 2 options. It's save formulas, view formulas. There's no sorting, so we don't need a third option actually. So, and something I'm going to do here in is I'm going to direct my user. Actually, I already have it right here. This is an invalid choice. So if the user types anything other than 1 or 2 or 3, we'll tell them it's an invalid choice. So this one would be, we wouldn't just want else, because then 3 would produce this result. And actually, you know what? I'm going to have this check for 3. I'm going to say if their choice is not equal to 3. So remember, the way these if, else, if structure works is once it finds the first one that it evaluates to true, then it will execute the code that's in that within those brackets, and then it will skip all the rest. So here, if I've gotten this far, I know it's not 1, I know it's not 2. Here I can check to see, well, is it if it's not equal to 3, then I'll issue the user this this error message. The string choice is an invalid choice. And we can have the else with either an empty set of brackets, or you could issue a statement maybe and say goodbye. which you probably wouldn't even see if you're if your console window doesn't stay open, but we can put it there anyway. Okay, so I don't know if copy and paste helped me a whole lot in this particular function, but at least gave me a roadmap. So this is the changes I've made. I'm now receiving a string from the user, and while that string is not equal to 3, I'm going to show them a menu, and I'm going to get their choice. And maybe we should prompt them for a choice. Let's do this. Let's say enter a choice. Maybe lowercase c there. Okay, and then we get that choice as a string. If that string is the string one, we'll call a certain function. And let's call this function add formulas. Else if the string choice is 2, then we want to view formulas. And if that choice is not equal to 3, they typed something in wrong, let's tell them invalid choice. Otherwise it was a 3, and then we'll say goodbye, and the while function will loop back, and it'll since that is a 3, this will be false, and then exit. Okay, that's just one way to structure it. You can structure it with a do while. You can use integers and have that get char like we had before. I'm just giving you a little bit different look here. Okay, program a little, test a lot. I'm going to go ahead and compile this. Obviously our formulas here, we haven't defined them yet or declared them. So let's go ahead and declare them, and then we can compile. Okay, so I'm going to declare that void function add formulas, and I'll say this formula prompts the user to create a file and store formulas in it. Instead of prompts, I'm going to say this function allows the user to create a file and store formulas in it. View formulas. This function allows the user to view any text file, and that's really what it's doing. It wouldn't have to necessarily be one of the files that our formulas where it was in. It could be any other text file, but we'll say this function allows the user to view any text file. Okay. Alright, so now that we have declared those functions, when we try to call them, it's not going to give us an issue. It may tell us that we haven't defined the formula yet. And you can see here it does. It says undefined reference, add formulas and view formulas. So these functions, we've declared them and we're trying to call them, but they haven't been defined yet. So I just want to make sure my menu is working and looks right. I'm going to comment these out just for now and then recompile. Okay. So we have add names to file, view names in file, exit. If I type 3, it should exit. It says goodbye. There we go. One thing I am going to do is I am going to put a second inline up here. Compile again, just so that there's a line of space after my menu. Okay, that looks better. Add names to file, view names in file, exit, enter a choice. And 1 and 2 shouldn't do anything now, but it will loop back. And we want to check and make sure that it does. 1 and 2 both loop back. If I type in something other than 1, 2, or 3, invalid choice. And doing it this way, where we're reading in a string, that will keep us from having any issues with the user typing something in that's not an integer. Just a little bit more broad, painting a broad stroke here. So then 3 exits. Okay, so everything's working like we want it right now. Let's start with the add formulas function. I'm going to comment this back in and then come down here and define it. Void add formulas. Okay, and then I'm going to go back to that main CPP file again that I had in the other that other link, not in this Unit 2 review. Oh, and be careful if you hit compile. When you hit compile, it may ask you if you want to save into this location here, so make sure it's not in that location. So I'm going to open up this one that I'm copying and pasting from, add names. Okay, so here's the add names function that we did in the file IO. I'm going to grab it, all the stuff in there, and go back here, add formulas, paste it, and then I'm going to go through here and make some changes. String name, I'm going to change that to string formula. String file name can stay the same, and then this vector, instead of string names or v names, I'm going to call it v formulas. Enter the file name with the extension. Okay, enter the name, enter a formula to add to the file, and string formula. While string formula is not equal to q, v formulas push back string formula. Enter another formula, or q to quit. Okay, and then here save data, passing to it the v formulas function, or vector, I'm sorry, and then the file name, and then we're passing to it true, which is the append mode aspect. So we're asking the user for the file name. Now if you wanted to, you could comment this out and then just like hard code the file name in, something like this. If you wanted to do that, it would just save you a little bit of time, but it would also limit, or it would give you a little less flexibility in your testing and of course in your final program. I'm going to just have the user type the file name in. Okay, I'm going to compile again. So I'm going to add name, and this still says names to a file. I just realized that. Let's go back up here and change this. Add formulas. View formulas. And again, that's one of the drawbacks of copy and paste, especially in your strings. You can leave things in there that shouldn't be there, but it does save you some time if you can copy some meaningful code that just needs some slight changes. Okay, so let's try that again. Add formulas to file, view formulas in file, exit 1, enter the file name with extension. So I'm going to call this kinematics. Any of the pre-engineering students in this class would know what kinematic equations are. Those are the equations of motion in 2 dimensions. So I'm going to call my text file kinematics.txt. Enter a formula. Distance equal v naught t plus 1/2 a t squared. There's one formula. Enter another formula. Velocity is the derivative of the distance, so it would be v naught plus AT. And I'll quit at that point. Okay. And we haven't written the viewFormulas function yet, but what we can do is go to that file and make sure that the file was created properly. So I'm going to go to my unit to review, and there's the text file, kinematics. Open it up. There they are. Okay. Okay, so that header file, we didn't have to do anything with it. It's a portable thing that we just included in our project, and we can implement it directly, use it directly. Now there are some variable names in here that were kind of geared towards our last project, like you know, here I did data in here, but here I had string name, so that, you know, they're not names anymore, they're formulas. You could give this a little bit more generic, call it like string data maybe, or something like that. But you know, we just imported it, and that's kind of the idea behind the black box analogy and mentality. When you create a header file, you don't need to know how it does what it does, you just need to know what it does and how to use it. And that's what we did here. We knew that this get data function, or actually the save data function, receives a vector and a file name, and then a true false, do you want to append, and then it does its thing. It takes the vector and creates the file name, and then dumps all of the strings that are in the vector into the file. Okay, so add formulas is good to go. It's cooking, everything's fine. Now let's program the view formulas portion. Okay, so below my add formulas here, I'm going to create a void view formulas function. Okay, and going back to that files IO, I'm going to look in my view names. I'm going to copy this, and I'm going to go ahead and close this now so I don't get confused between the two. Back to this main, paste. Okay, so view formulas. Let's change everything that says names to formulas. I'm going to copy that. Enter the file name with extension, and vformulas gets get data file name, vformulas at. Okay. Other than that, get lines here, I don't think we need to make any changes. So let's try that out. Okay, so now let's view formulas into the file name kinematics.txt, and there they are. Fantastic. And I'll exit. Okay, so in under 30 minutes I took code that I already had and copied and pasted and created a new working program here. And that's what the idea behind creating programs with these components that are modular, that you can add to other projects, add these classes, and well, actually we haven't created classes yet. Add these files that have code that's reusable. Okay, so that concludes the review. The biggest thing about programming is, can you look at a pattern, can you recognize the pattern and then repeat it? In programming, you will, and not only in programming, but in really the workforce in general, you will be given models of standard operating procedure, and you look at the pattern and you have to repeat the pattern. And that's the biggest thing about programming going forward. If you do find yourself programming in the future, you will inevitably come to a point where there's something you don't know how to do, or even maybe a formula you don't quite know how to use, and you have to do the research and figure out how to use it. And that research will amount to, Googling what it is you're doing and looking at that formula online and looking at examples online, and can you understand how the example, the pattern that the example is laying out, and can you then take that pattern and implement it. Okay, so for this test, I will go ahead and let you know that it'll be a lot like this, only I'm going to have you do some string manipulations. So that chapter 8 the chapter 8 string functions like find and substring. Take a look at some of those examples and look online for those examples, and look in your textbook for those examples and how to use them. On the test you will need to use them. And actually I already have the test open. Why don't we just take a look at it and talk about it together here. Unit 2 exam. Here is the exam, what the exam's asking you to do. Okay, it says write a C++ program that stores data to a file, to a text file. The data will be a person's name followed by their age. The program should have a menu that asks the user if they want to see the data in the file or write data to the file. Have a header file that contains two functions. One gets the data from the file and the other puts the data into the file. So we've already got that header file. The write data option from the menu should call another function that receives the data from the user and that other function's in our header file. Once the user has finished typing a name, it should prompt them for the person's age. These two pieces of information should be stored in a vector as a single string entry delimited by some character of your choice. This function should then pass the vector to the function in the header file that stores the data into the text file. Okay, so what I'm wanting you to do is this text file, up until now you've just been throwing lines in it and then just getting the lines out of it and displaying them. Now I'm asking you, in every individual line, treat those as if they are comma delimited, or you can use whatever delimiter you want. And a delimiter is just a character that will separate the pieces of information where you have multiple fields or multiple pieces of information in a single row. So we're using a text file to kind of mimic a database, or we're utilizing it as a database. So in this case, your database, the row, the record, is a person, and the fields are their name and their age. And we're separating those fields with some character that you can recognize. So you don't want to use something like an apostrophe, which someone's name might have. You want to use some character that's not going to be in a name. Comma is a common delimiter, semicolon, or maybe the bar, a vertical bar. So you're going to concatenate those two strings together with that, putting that delimiter in between the two. And then when you read the data back out, you'll use that get data function in the header file, and you'll get all the data. And then once you have it in the view names or view people function, it's going to take the string, each individual string from the vector, and then you're going to parse out the name and the age using that delimiter. So what the find function does, if you remember from chapter 8, and you of course can look at your text to give you reference here. You can also Google this C++ function. The find function returns the integer, which is the location in the string of that particular character. And you can pass to it a string, but like you can pass to it a string that's just a single character. So you can pass to it the string semicolon, for example. And then that string function, of course, operates on the name. So maybe this is your name variable. So that just attaches onto the end of the variable and calls that that calls that function that operates on that. This is the string. Okay, so the find function will give you the index, and then you use that in your substring function. The way the substring function works is you give it the starting position, and then you also tell it the length of the substring. So, in your file, you're going to have a line that looks something like this. And what you need to do is parse out the first portion using substring starting at the beginning, and the second parameter is the length. And so the length would be the from the starting point, which is 0. Remember, a string, each character in the string is 0, or it's like an array. So it's a 0-based index. The letter V here is at the 0 position. So in your vector, let's say this is my vector names. That will give me the very first vector, and then I can use the find function to find the semicolon, or whatever delimiter you use. That returns an integer. That integer is the integer location for that character. And so the length here would be this result, the find, that integer minus the beginning integer, which is 0. So in that case, this is the length. But in the case of the second portion here, your substring is going to start at that position, and actually you want to add 1 to it, so you start here. Add 1 to that find, and then the length is going to be the whole length of this thing minus that spot. So be careful with your implementation there of the substring method. You have to do a little math if you want to create integers that can store the positions and where your find the returned value for your find function. Then that's a great idea. That will help you out. Another thing to be aware of, you want to make sure that your header file isn't giving you empty values. So what you can test for with that find function to make sure, if you start getting out of range exceptions when you're trying to debug this, that means that you're trying to, if you try to pull a substring that's longer than the actual word, like for example, if this was my string and I was starting here and I wanted to pull a substring starting there that was 5 characters long, well, that goes outside the range of the string, so you're going to get an error. What you can do if you keep getting that error and you're having trouble debugging it, try testing to see if so let's say it's v, maybe you call it v names at in find your delimiter. If that is equal to -1, what this function does, this find function, if you look in your text and read about it, it returns a -1 if it didn't find that character at all. So if you're in your vector, if you've got an empty element in your vector, then this will return a -1, and if that's the case, you can use you can either break out of your loop. You really wouldn't want to break out of the loop. You'd probably want to use continue. What that will do, I'm struggling here in this Word document. What the continue function, what the continue keyword will do is, if this is true and it executes this continue, what the continue does is it skips everything else in the loop. So like we're assuming that this whole thing's in a loop. Why don't I just open up dev instead of trying to type this into a type this into okay. Okay, so if vnames at and find, and again we're assuming you're using that delimiter, is equal to -1. Okay, we're assuming that this thing is in a for loop that's looping through your entire vector. In less than vnames dot size, something like that. Okay, so let's say you've got more code here, and let's say this is the code where you have your substring methods, and that substring method is the one that you might have issues with if you're trying to parse out a name and an age in an empty string. Then you might get this error. So what the continue will do is it will skip any remaining code in a loop and then start back at the beginning of the loop. So what that will do then is make sure that any of the elements that you might have in your vector that are coming in empty, they aren't going to throw an exception when you try to parse a string out of it. Okay. So this exam, that's the challenging part of it. Everything else you've already done before. The challenging part is using this find and substring methods from Chapter 8. So good luck with it, and happy programming. If you have any questions, let me know. You can email me your problems or your code, and I'll help you as best I can. Happy programming, and make sure you know yourself.